Now, brilliant. So, what we're going to get here, guys, is just going to do number 15, okay? So number 15 is integrate sine 6x with respect to dx, okay, with respect to x. So, do here is the limits stay on the outside as pi over 12 and 0, okay? And then when we do this, we're going to get a sine changes to minus cos. The 6x stays the same. Now, what you got to do is you got to differentiate the angle. And once you differentiate the angle, you get 6, and it's 1 over that. So over 6. Okay? And then what you're going to have next is this here, and you have your two limits. So what we're going to get is minus cos. So if x equals pi over 12, 6x will equal pi over 2. Pi over 2 over 6 minus bracket. Now, what we have next is minus cos 0. 6 times 0 is 0, all over 6. And then what we're simply going to have is minus cos 0 is 1 minus 1/6, which is going to get us plus 1/6. Okay, quite an easy question. Now, so guys, we're going to move on next. Do the likes of question 18 as an example. 9c4, put the dx on the outside, you get 1 over x squared. Change to 81 to what, guys? Can anybody remember? 9 squared. Then we have 1 over x squared plus a squared. When you integrate that, it equals 1 over a tan inverse x over a. So that's what we're going to do here. We're going to get what is it? It's going to be 1 over 9 tan inverse x over 9. And it's going to be going from the two limits, which are 9 and 0. And then we're going to get 1/9 tan inverse 9 over 9. Anybody? 9 over 9 is going to get us to 1. Okay, doesn't undo that part. So tan inverse 1. And then 0 in place of x, guys. Minus 1/9 tan inverse 0. So tan inverse 1 is, anybody? Pi over 4. We're only using radians in here, which is pi over 36 minus 1/9, which is just 0. So pi over 36 for that one. That's question 18. Is there anything specifically that you guys would struggle at? So guys, just bring it back to a bit of trigonometry, okay? There's a rule for cos 2x. Anybody know the cos 2x rule? Cos squared x minus sine squared x. Everybody cool with that? Now, it's too many variables there. There's cos squared x and there's sine squared x, okay? So what we can do next is we can change them into one object by using by combining this formula in here. So we can say that, for instance, if I want cos squared x, all what I have to do here is this. I'll just simply say change sine squared x into cos 2x equals cos squared x. Change the minus sine squared x into, so sine squared x on its own, if I move the cos squared x over the other side, sine squared x will equal 1 minus cos squared x. Everybody happy with that? So then it's going to be cos squared x minus bracket 1 minus cos squared x. Then we're going to get 2 cos squared x minus 1 equals cos 2x. Bring it over to your side and we get cos 2x plus 1 equals 2 cos squared x. And then it's just going to be basically a half of both of them, isn't it? So it's a half cos 2x plus 1 equals cos squared x. Are we happy enough with that? Using these two rules up here, I was able to change them into this here. Alright, now once you know how to make that, what we're then going to do is we're going to use this rule here, and we can do it for 17 part 2 first. So 17 part 2 wants pi over 2 0 cos squared x dx. So what we're going to do is we're going to change it into the integral of pi over 2 0 a half bracket cos 2x plus 1 dx. We cool with that? Then bring the half to the outside. So bring the half to the outside. Let's try that again. Okay, makes no sense. Now, just scribble that out and put it out here. Okay. Now, what's going to happen next is we're going to integrate that. Now, once when you integrate cos 2x, what you get? So I am currently doing 16 part 2. So what you get when you integrate cos? Sine 2x over 2. So it's going to be sine 2x when you integrate cos 2x. Differentiate the angle, which is going to be 2 on the bottom. Integrate 1 x, and there's a half outside, and that's going to be pi over 2 to 0. So what you can do is you can leave the half to the very end, and you can just open up a massive set of brackets, or you can multiply in the 2 right away. It doesn't matter. So we're going to get is if x equals pi over 2, what's 2x? Pi. So it's going to be sine pi over 2 plus oh wait a second, that's written slightly weird. It's going to be sine pi over 2 and all over. Oh wait, I wrote it right the first time, never mind. 2x is pi, so sine 2x is pi. It's all over 2, and then x is pi over 2. Take away when you plug in 0, it's going to be sine 0 over 2 plus 0. Now what happens here, guys? What's sine pi? Sine 180 minus 1 to an edge. Oh no, sorry, you're right, 0. It's 270, that's minus 1, you're right, sorry. 0 pi over 2 sine 0 also 0. So it's going to be a half of pi over 2, which is pi over 4. Now, keeping that knowledge here, what we're then going to do, so we've done 17 part 2, or sorry, 16 part 2 is what we did there. Using the knowledge you gain for 16 part 2, formulise a way to come up with 17 part 2, or sorry, 18 part 2. So, for 17 part 2, we combined these two formulas here to make the formula a half cos 2x minus 1. Was it minus 1 or plus 1? It's plus 1. Equals cos squared x. We now have 18 part 2. And what's the difference between this one and the last one? It's now cos squared 2x. So double the angles. So it's going to be a half. What will this be? Cos 4x plus 1. Substitute in. So pi over 4, 0, cos squared 2x dx. It's the same thing as pi over 4, 0, half cos 4x plus 1 dx. Now, once that's done, move the half to the outside, and then we're going to have pi over 4, 0, cos 4x plus 1 dx. Are we cool with that? Any questions? Okay, be surprised if you remember all this. Now, integrate it. What happens when you integrate cos 4x? Plus sine x plus sine 4x. Differentiate the angle over 4. Differentiate the 1. X. Half on the outside. 4 over pi and 0. Now, if x equals pi over 4, 4x therefore must equal pi. So, it's a half, open brackets. Now 4x is pi, so it's going to be sine pi over 4 plus pi over 4 minus sine 0 over 4 plus 0, close bracket. Okay, all of this here, it's all 0. The second part, sine pi, 0. Half of pi over 4, pi over 8. Is that right? So that is basically, that's basically 16 part 2 done. That's 18 part 2 done. Now to finish this off, I'll do 19 part 2. 19 part 2 has a little trick to it again, okay? So what we're going to do is we're going to go back to our original two formulas. Looking at these two here, we're going, okay. Now, if I do this properly, I can say that cos squared x equals 1 minus sine squared x. Would you agree with that? Then I'm going to get rid of this cos squared x here. So I'm going to get cos 2x equals 1 minus sine squared x minus another sine squared x. And then I'm going to get cos 2x equals 1 minus 2 sine squared x. Then I'm going to multiply both sides by minus 1. Here, I'll do it in one go. Going to bring the 1 over to your side. So it's 1 minus 1 plus cos 2x. Then I'm going to multiply both sides by minus 1. So I'm going to get 1 minus cos 2x equals 2 sine squared x. Going to divide the other side by a half. A half, 1 minus cos 2x equals sine squared x. Everybody cool with that? Now, I don't have sine squared x. I have sine squared 2x. So, what's going to happen here, it's going to be sine squared 2x. That's going to be a half 1 minus cos 4x. Is that right? Going to substitute that in. My pi over 8, my 0, my going to put the half, it's going to be a half 1 minus cos 4x. I'm just going to shift the half to the outside. A half bracket 1 minus cos 4x dx. Okay guys, what happens when you integrate cos x? What does it turn into? Huh? Here we are. So when you integrate cos x, you get sine 4x over, differentiate the angle, divided by the differentiation of the angle. Differentiate 1, x. Half on the outside. Pi over 8 and 0. So this time, guys, x equals pi over 8. If x equals pi over 8, what does 4x equal? 4x will equal pi over 2. So it's going to be a half. X is pi over 8 minus sine 4x. 4x is pi over 2 divided by 4. Take away x, which is 0, minus sine 0 over 4. What can we say about the zeros here? Huh? Just oh yeah. Cancelled. A half pi over 8. Now pi over 2. 1. So the answer here is going to be pi over 16 minus 1 over 8, or whatever that is. You could also just factorize out more numbers, whatever you want, whatever way you want to write it. Okay, so there guys, we did 16 part 2, 18 part 2, and 19 part 2.